Hello and welcome to 1.2. We're in linear functions again. A lot of modeling with application, which is good. And I think you've noticed these are probably a little bit longer than normal, but there are only 3 sections in this chapter. So we're doing well and we're halfway through. Okay, let's go to 1.2. All right, today we're going to do supply and demand, equilibrium, and linear cost. All right, so these are all business related. Remember, this is actually a business calc, so we need to get some of this in so you get full credit for it. We're talking about independent variable. You should remember this from science. So that's when you substitute it into a function, produces an output or a solution. Independent. Dependent are the obtained from the substitution. So remember, your independent is actually your x and your dependent is your y. So when we go through here, we have function notation. Just another quick review. So you know that g of x stands for y, right? It's the name of your line. So if you actually graphed this on a line, you'd go to 7, you go up 4 over 1, and you graph your line. Well, if you have multiple lines or multiple functions, so you have a parabola on here, you need to name them so people know what you're looking for. So this guy would be g of x. This guy may be f of x. And this guy would be h of x. Remember, the g, the f, h of x, and f of x all mean y. So nothing too fancy here. So we're going to take the g of x out. We know that's the same as y equals 4x plus 7. When I say find g of 5, so in here I've replaced the x with 5, which means on this side of the equation you would like to do the same. So 4 times 5 plus 7, and your answer is 27. Pause and your turn. So you should have taken 4 times negative 4 plus 7, so negative 16 plus 7, and gotten negative 9. Okay, how did you do on your g of x? Okay, if you notice now, I've given you a little bit different here. Remember, we told you g of x meant y, so now I've given you the y value. So you should have said 9 equals 4x plus 7, subtracted your 7, so 2 equals 4x, so x equals 1/2. I hope you did well. All right, let's continue with something a little more challenging, hopefully, coming up. These are your definitions. I think we should go over these just a little bit. They will not be on your, on your test, but they will be talked about. So demand, as the price of an item increases, consumers are less likely to buy it. Less likely to buy. Okay, law of supply. As the price of an item increases, producers are more likely to see an increase in profit, so the supply increases. I know the wording is weird. All right, so we got Greg Taubin, manager of a giant supermarket chain, studied supply and demand for watermelons. So we're talking about watermelons here. He's noticed that demand increased as the price decreases. Makes sense. Cost less, we're going to buy more. He has determined the quantity in thousands, demand weekly Q, and the price in dollars per watermelon P are related in the following manner. So price, which is your demand function, is equal to 9 minus 0.75 Q. Find the quantity of watermelons demanded at a price of $3.30. So if my price is $3.30, I am replacing this, or the demand. So the $3.30 equals the 9 minus the 0.75 Q. So subtract your 9. So when you subtract the 9, you get a minus 5.7 equals negative 0.7 Q. Divide by the negative 0.7. Oh, I forgot my 5. Sorry about that. Divide by the negative 0.75, and we get 7.6 Q. So that means this is in thousands. Remember, your quantity is in thousands, so I have that 7,600 watermelons. I'm running out of room, so I'm going to stop. Okay, the quantity of watermelon supply decreased as the price decreased. So price P, and so this here, now we're on supply with Q. And remember, these are both P. So I can find the price from the demand or the supply. So 330 again. So I want to know how many I should supply. So I'm going to do 330 equals 0.75 Q divide by 0.75. So according to this, I should apply 4.4 or 4,400 watermelons. Here, I'll just WM, much easier. All right, I wanted to show you a graph over here so you understand what's going on. So right here, your price, remember it had a negative, so this is a negative slope. So as the number of watermelons increases, the supply, the price goes down, which makes sense, supply and demand, right? Here, this one here is your supply. As your supply goes up, our price goes up. So I have more, I can charge a little bit. Right here in the middle, where they meet, is called your equilibrium point. So that's when supply and demand match. So right here, this matches when I have 6,000 watermelons and I'm selling them at $4.50 a piece. That's my supply and my demand match. If you look here, one of your points is 4.3. So when I have 4,000 watermelons, I'm selling them at $3. Well, over here that matches because when I sold it at $3.30, I had 4,400. It makes sense. So this is what your graph looks like. Where they meet is the equilibrium point. Later on, known as a break-even point when we start talking about money. Way more interesting, I think. Okay, just a short description so you can see it. It's found when the prices of both supply and demand are equal. The equilibrium, oh, I already talked about this. Equilibrium quantity for the watermelon. Remember when we had 6,000 watermelon? Is at our equilibrium point, and we were selling them for, I think it was $3. Or was it $4? $4.50. And we sold them at $4.50. That's when supply equaled demand. Plug the value Q in either the demand or the supply function. The value of Q is, what do we want here? Oh, this is this down here. The value of Q is 6, is not the 450. So I want to make sure that you realize which one is the quantity and which one is the price. Okay, same watermelon problem, but this time I'm giving you a different function that they created. So you try it. Pause and give it a shot. The quantity of watermelon at 330. So again, we're putting the 330 in for here. And it says demand, so we're in the demand function. So we do the 330 equals the 10 minus 0.85Q. Subtract your 10, we got a negative 670 equals negative 0.85Q. Divide by negative 0.85, so your quantity is 7.88 or 7,880 watermelons. Okay, the quantity of watermelons supplied, so now we're at the supply at the price of 350, so we're at this equation. So 330 equals your 0.4Q divided by your 0.4, so the quantity is 8.25. Remember, this is thousands, so that's really 8,250 watermelon. Equilibrium quantity. So I asked for quantity. I'm actually going to make you find quantity and price just to make sure we're okay. This is when they're set equal to each other, right? That's where they meet. So I just set the two equations equal. So 10 minus 0.85Q equals 0.4Q. Subtract the 0.85. So 10 equals 1, or add the 0.85, I'm sorry, 25Q. So Q is equal to 8. So it's balanced at 8,000 watermelon. All right, I also would like to know the price. So, because that's really what's important here, I can plug the Q in either to the demand or the supply because they both equal price. It doesn't matter, so just pick one. I'm going to pick the 0.4Q because that's the easiest. So if I do 0.4 times 8, we get 320. So I can sell 8,000 watermelon at $3.20. That's my supply and my demand match, which is what we kind of liked, right? Marginal cost, rate of change. Marginal is cost is the rate of change of cost. So how is the cost changing? Remember, change is always your slope. So this is nothing new, just different words. So marginal cost, that's what the C of x stands for, is mx plus b, because it is just linear. M, marginal, is the slope. B is my fixed cost, or my y-intercept. So when you read this, a video company has a startup cost of $5,000. $5,000 is not ever changing. So that's my fixed cost. So that's fixed, so that will be B in my equation. Must spend $12 to produce each video. So it's $12 per video. Since that's $12 per video, that is a slope. It's $12 to one video. It's a slope. This is my marginal cost. This is what's changing. So that's my M. Create the cost function. All we do is write out now. So the cost function for my video is equal to 12x plus 5,000. All right, try yours. This deals with the mechanic. Okay, he has a startup cost of $34,000 because that's his tools and his garage, and this changes per vehicle. So this is fixed and this is marginal, or our slope. You should have had an equation of y equals 65x plus 34,000. I hope you did well. All right, let's keep going here. Oh, sorry about that. Let's make this go back up. All right, we're talking about break-even point. This is like our equilibrium points where things match. So revenue is how much money you actually bring in, not what you make, but what you bring in, what's in the cash register. It's what you charge, P, times how many units you sell. All right, pretty simple. Okay, profit is your revenue, what you actually have in the cash register minus the cost of making it, which makes sense. So like if you're selling popcorn, you have $100 in the register, you have to subtract out the cost of the popcorn to figure out your profit, correct? Break even is when the revenue matches the cost. So I have zero profit, in other words, is what that means. Let's go. Just an example, my cost function is 20x plus 100. So you're looking at this line right here. So you start at 100, you go up 20 over 1, and this is the cost. So right here, until the break-even point, if you noticed here, my cost line is higher than my profit line. So I am losing money. At the break-even point is where they switch, and my profit line is higher than my cost line. So this is where I start to make money. So the more I sell now, the more profit I make. Right here is your break-even. So that's when cost matches revenue. All right, why is this not lined up? I don't know, we're gonna have to figure this out. Okay, so what's the profit? And I know I forgot to put this in here on yours. If 20 units of feed are sold. So 20 units, to me, looks like I don't have a profit, I'm at a loss. So let's find out. So I've got, the cost is 20x plus 100. My revenue is 24. We can do this two ways. We can first actually create the equation. So I can say my profit is equal to 24x minus 20x plus 100. Okay, distribute your negative. So I have 24x minus 20x, which is 4x minus 100. It's my actual profit. And then I can just plug the 20 into here. So if I plug my 20 into here, so now we're on this part, my 20 units. So if I want my 20 units, I would take the 4 times the 20 minus 100, which gave me a negative 20, which is what I thought would happen. I am still losing money at 20 units of feed. All right, how many units has to be sold in order to create a profit of 900? So I want to know when I'm making money. So I'm going to put 900 in here. I'm going to use this equation because it's easiest. Equals the 4x minus 100. So let's add the 100. So $1,000 equals the 4x. Divide by 4. X equals 250. So I have to sell 250 units to make $900. Making sense now? Okay, your turn. I want to know the break-even point The profit or loss is 120 units are sold. What's the profit? Okay. Is there a profit or loss if 20 units are sold? If so, what is it? And how many units must be sold to reach a profit of 2,000? All right, let's find our break-even point. So pause and you've done this, right? So now break-even means to set them equal to each other. So 20x equals 35x plus 250. Subtract, so I got a negative 15x equals 250. Divide, so x equals, calculator, negative 16.67. What does that mean? And my break-even point is at a negative 16 units. Okay, that's not possible. So since I can't have a negative number of units, this means I do not have a break-even point that makes sense, which means since this is negative, I will never make money. So this means the cost is always higher than the revenue. This is a poor business plan. All right, if you presented this to someone, they would never lend you money because you will never make money. You need to change something, probably what you're charging. Okay, so is there a profit or loss? Well, right now, because of this, I know it's a loss. I want to know how much I'm losing at 120 units. So we need to figure out our profit, right? So we know profit is going to be my revenue minus my cost. All right, so now we've got the profit is equal to a negative 15x minus the 250. Let's plug in our 120. So now I got profit equals a negative 15 times 120 minus the 250. And my profit is negative 2,050. I'm going to lose $2,050 when I sell 120 units. You are really not doing well. How many units must be sold to reach a profit of 2,000? All right, you're going to, right now you already know this is not possible because you will not reach a profit. All right, it will be a negative number. So when you solve this mathematically, there should be a negative number when you're done. So you can go 2,000 is the profit I want to reach. We're going to plug it in, whoops, to the, maybe, there we go, the negative 15 times, oh, I didn't need to do that, minus the 250. So add your 250, divide by your negative 15, and x says, still need my, I should have had these done beforehand, sorry about that. Negative 150 units, which makes sense. It is not possible. I cannot have a negative number of units. All right, good luck on your homework. Make sure you're posting on the discussion board, and I'll try to get back to you. Have a great day. Bye.